Hello, hello. Welcome to our TED Talk class. Today we will speak about algorithms, and we will speak about one TED Talk, which name is How Algorithms Shape Our World. It's a funny TED Talk, and I don't know, do we have a volunteer to summarize it?
But you should
Diana,
explain what an algorithm is. Ivan, you are the expert.
Algorithm? Well, it's it's a pretty simple thing, you know. It's an instruction, and I think that first one who invented algorithm was how to say it?
A woman. Mom, go there. Do this.
Right. I think so. They use it in cooking, you know. Any cooking recipe. Do we call this recipe?
Receipt. No, recipe. Sorry.
Recipe. So recipe is an algorithm already. It has now some number of steps which you should reproduce. And then you will have the result. So that is the algorithm, nothing new. But it's a Greek word, I believe, and it's invented in ancient Greece by some guy. So that's all. And I think that we can see algorithms everywhere. You know, every instruction, every guide provide us an algorithm. When we have a lot of them on our site, on our Menrook site, about how to join Telegram chat, how to attend the lesson, and so on. So Teacher Lee is an expert by writing algorithms. He wrote a lot of them. So that's a simple notion, I think.
So I have a question.
Yes.
Is any instruction an algorithm?
Well,
an algorithm is a set of instructions. Yeah.
Right. It's if your instruction has more than one step, it's algorithm already. It's it must not be too complicated. It must not have branches. We call it branches. You know, if you see that, do that. If you see that, stop the algorithm. Something like this. It's not necessary. Just a few steps enough to be an algorithm, but not enough to be a program. You know, so it's different.
An algorithm sometimes is called a subroutine. It's a small reusable code that if you give it some input, it'll produce some output. You could have an algorithm to add two numbers together. You input two numbers, the sum comes out. You can have an algorithm to subtract two numbers. So they can be very simple. They take one or more inputs and give you an output back, like a black box of computer code.
And I think that we used that algorithms during Stone Age, I think, but only Greek, one Greek invented this word, so we started to call it so. And I can remember from my math studies that the first one written algorithm was about finding prime numbers. So, do you know, Diana, what is prime number?
Prime number. This is the number which can be divided by itself, something like that.
Right. So the number that does not have any dividers except one and itself. So if you think about this more, it's not there are many complicated questions about these prime numbers. How to get next one? How to get previous one? What is the distance between them? How to get one that more than 100, for instance? And it was a complicated questions for ancient Greeks. They built an algorithm that provided a way to have a list of prime numbers, and it's first written algorithm, I think. It was funny for me to study that because you know, they have a computer exactly. This Greek invented the algorithm, but the executors, or how we call runners of algorithm were his slaves. They execute that, and they provided a list of prime numbers up to 1,000, like that.
Yeah, so he was the brain, actually. Yeah. So and all the dirty job was done by somebody else. Nice.
Yes. It's a way to what's the word for that? Escalate? No, to
delegate.
Delegate, right.
Yeah.
So it's when you need to delegate some work to someone, and you don't want to show the all details. You just write a simple algorithm, take it. You know, my wife do with me it's all the time. I have the list and I go to the shop. It's algorithm.
Yeah.
Kind of. Okay, so we cleared this up, right?
Yeah, guess so.
Okay. Let's go back to complicated algorithms, to nowadays stock options, how you stock markets, and all these things. And it's interesting because maybe you don't know, but you know, we can see in the Hollywood movies how stock markets looks like, right? Many people on the phone with monitors see and trade. Sit and trade, but actually it's not true for 10 years already, because people are too slow to trade. People just second driver here, just to prevent some catastrophe. When something goes really wrong, the people here has a red button that speaker mentioned, just to press and stop all that. And we have many stories.
People are not yelling over there, you know, just waving hands. No, not doing all this. Oh my goodness.
It's useless, because why you raising your hand? It's already done. Everything.
Okay.
Those are the people that don't have a computer.
Right. So they just standing there, just, you know, for the picture, right? Because they're useless.
But why we have to have these red buttons? Because nothing is perfect, and this program makes mistakes, and this program has a influence to each other and change their behavior, and sometimes it goes to wrong direction. And we know many stories when big corporations were bankrupted because of mistakes in codes. So that's why we have a man to press a button, just in case if total loss in more than $1 million, for instance.
So, but if this clever program makes mistake, how can a silly man, you know, just prevent that? So the mistake is done. So how can he be quick enough to prevent that, to press this red button?
It's kind of different. You know, he must not be too smart. He don't want to patch the program. He don't fix something. He just sit and see on his monitor that something goes wrong. You know, we have too much losses, and he just stops all the programs. Just stop it, and then call programmers, and they will find and try what goes wrong. So it's kind of how we call that. I don't know.
We're just a safety stop is all we are. If things are starting to go snaky, we just say stop, and we hope it stops at a good place instead of at a bad place.
I see. And usually we had some soldiers, some sailors on the ships that watch to the forward to make to see a land. It's something like this.
Yeah, lookouts. Yeah.
How we call this? Lookouts?
Lookouts, looking for land. Or scouts look for danger.
And how we call the man? His job is I don't know, to guard the camp, for instance. When everyone sleeps, the one is on duty. How we call him?
Just guard or sentry. His job is just to alert others that something's happening.
I see. So I think it's a close analogy to what we have on stock market. What people do on stock market now, they're just guarding their stores, their programs.
Yeah.
But what is very interesting is that, do you remember these graphs that speaker provided? Some different, because it's a war between two different algorithms. They do something strange. We just can't explain that. We just can't explain how they struggle with each other. But sometimes it's made these funny graphs.
Okay. So these graphs actually show this, how to say that? the improper work of these programs, of those algorithms, right? Like, or something, this knife thing you're talking about, this carnival thing, yeah, those graphs.
It's kind of symbiosis. It's kind of symbiosis. When two programs start to work with each other, and one has one algorithm, another has another algorithm, and they struggling.
Okay.
No one win, but we can see this strange war.
Let's give an example. Let's say there's two computer programs out there monitoring stock prices, and one program is designed, when it sees a price to drop, it starts selling its stock in that stock because it doesn't want to lose money. Maybe there's another computer program that looks for dropping prices for bargains, and it starts buying that stock. So this one guy sees a drop in price, so this one computer program starts selling. Well, when you start selling, that makes people see that and panic, so everyone starts selling. So this other computer program says, oh, everybody's selling, I'm going to start buying. Well, when you start buying, people see that and say, oh, it must be hot. So then they start buying. So one program is selling, because the price is dropping. Another program is trying to buy, which makes the price go up, and they start fighting each other. The price stops going down and starts going up. So now the two programs reverse. And it causes the market to kind of go unstable.
Right, and in programming we call it feedback. You know, you program made some action and it gets feedback. For instance, program start to sell something, price changed, it take it like feedback and stops selling. And sometimes it's made a cycle because it's happening again and again. Right, and we can see this teeth on the graph. Okay, and actually it's built a theory. Let me copy from Google. The study of mathematical models of conflicts and cooperation between intelligent, rational decision maker. It's called game theory now. And a big scientist, George Nash, was in front of that, how to call it, in the beginning of this theory. And now it's a very useful thing. I hear that people use that when they need to find solution for divorces, for instance. And I know that current president of America, Trump, invited a few mathematics to divide. I forgot the word for that. to divide all what they have with previous wife.
Property, yeah.
Yeah, so they use game theory during the divorce. And it's a guarantee that everyone will be in the best possible position. I like that. So it's not the best position for one, but it's a best possible position for both simultaneously.
Sounds like yeah, conflict resolution, something like that. Okay.
Yeah.
Right. So we have a lot of math about that, but let's forget about math completely. let's think about how it's. The speaker provided very interesting example. You know, just because of this delay between store, market, and computer of seller, I forgot how we call this. These guys who works on market usually, dealer maybe.
Brokers, dealers, brokers usually, yeah.
So just to decrease this delay between broker and stock market, they started to build fiber optic lines and start to modify the terraforming the yours just because of that. And now what's more interesting, they trying to find a point on the yours where will be equal distance to all the stock markets, and this position in the middle of ocean. And they will build the island and put the computers on that just to sell efficiently. It's kind of funny, I think, because it's also artificial. It's like a matrix. And because of this matrix, we will have a new island. But Matt asked, is it isolated island? I don't know. It doesn't exist yet. It doesn't exist. They just try to find a point when delay will be minimal to all the stock market in the New York, and I forgot where it's in Europe. London, maybe. We have a stock market in Russia, but it's a funny joke. It's our people don't play on this market, and the total amount of money on this market is something like what US market have in 1 minute. So it's just a joke. Okay. Anything else? Any questions?
I would say the point of the video is that people take data transmission times very seriously. If you're going to beat the competition, knowledge is power. And the faster you get the knowledge, the faster you can use your power. So if you're located close to the stock market computers and someone else is located far away, you're going to get the information a few seconds earlier. Now, humans can't make use of that time, but computers can make use of milliseconds and get an order in before this other guy's computer, because this guy's closer to the signal. So people are actually buying entire buildings, clearing the building out and putting nothing but computer servers in there just so they can receive the stock market signals milliseconds earlier than somebody that's, you know, another half a mile away. So their computer algorithms can make microsecond decisions and beat the competition. That's how serious this business is.
I agree, and I can see another conclusion. You know, when the stock market was slow and all the trades were made by people, nobody caring about this microseconds, because you have to have 5 minutes to make a trade, right? And it's enough time to call to Australia or something else. But because the technology is changing, because now it's fully automated process, we have this completely new problem how to be close. And this new problem involve our lives. It's change our planet. They build new lines, they do something like this. And I think it's a point of speaker, how algorithms change our lives. And let's think about other examples. For instance, I can think about postal delivery. You know, there are a lot of mass in this parcel sending. They have to calculate how to do that efficiently, and that's why we have this this fast delivery now, because they can count how to deliver it fast, how to use these trucks and airplanes to deliver goods. Sometimes it's funny from human point of view. Sometimes when I get parcel, I can read what the way was, what the path was for this parcel, and it's illogical from human point of view, because to get a parcel from China, the way is China, then somewhere in Europe, then Moscow, then me. Why? Because it's efficient from algorithm's point of view. So it's for me, it's another example when technology change a way how people interact. Gerard, please.
A question I made myself often is I pay 20 euros per year to Amazon, and they give me all the shipments for free. You know, how do they manage to make shipments so cheap? You know, to get some benefit from them.
I don't know. I think that it's closer to marketing field. They they give you cheap shipping, and they think that you will buy more from their market, not from another. That's what I think. Teacherly, what can you say?
We can hear you.
You're muted, actually.
You're muted.
I lost my mouse cursor. Okay. Yeah, I agree. It's all about winning customers. If you can do something a little bit cheaper, believe it or not, all the customers are going to shift to you, and the other guy's going to have loss of business and profit. So it's like the millisecond thing. Amazon, if they can give you, if they've got one little advantage over the other guy, like free shipping, you're going to get a lot more business than the other guy. So it's very cutthroat. How does Amazon do it? I don't know. They're even trying to come up with 2-hour delivery. And I'm going, who needs 2-hour delivery? That's crazy. But that's how cutthroat the business is.
Yes, and speaking about this example, I shared the story in our chat before, that we have now local taxi company that offer the price lower than petrol price. How is possible? They just want to kill all other taxi parks. That's what they do. So you now use it. We now can use it almost for free. Okay. Anything else?
I thought it's in Spain it's forbidden to sell under a price cost. Is it?
It's not legal.
It's not legal, I think.
Mm-hmm.
China is famous for doing that with steel. China sells steel so cheap because the government subsidizes the private companies so they can sell cheap, and then our steel factories can't compete. So our steel factories close down, we lose jobs, and then they've got the whole market because they drove all the competitors out of business by underselling everybody because the government is artificially supporting their low price.
I see. But our local markets like these tricks, once a week they do a big sale of something. They say this good costs almost nothing. And people go there to buy it, and in addition to this cheap product, they buy everything else, and that compensates the price difference. So it's just a trick, I think. Okay, okay, let's go to the questions, and we have a few of them. Okay, let me share the link. And I don't know where to go, Diana. Can you point us? What is interesting? Do you have any questions? No. Okay, so my question is.
Just a moment. Okay.
So my question is, can you provide some examples of where you encounter algorithms in your life? We provided a few, but I think we can think about more. So we provided cooking recipe, right? What else? Shopping list. What else? What do you do by algorithm?
Well, actually, like morning routine. It's kind of an algorithm which we do every day. So it's kind of the same things over and over.
Okay. And let me copy another thing to our chat. I try to make an anecdote. Try to translate an anecdote in Russian anecdote, and it's let it be a riddle. So, a wife sends her husband to the shop and says, "Buy a loaf of bread, and if there are eggs, buy 10. How many loaves will he buy if there are eggs in the shop?" Can you solve that?
You should get into the mind of the programmer. I think mission is impossible here.
I think it's an anecdote referring to uncertainty of our natural language. So when we speak in natural language, not in program code, there are many reasons to make a mistake.
I send you to buy bread. I say, go buy bread. If there's eggs, buy 10 loaves of bread. So he goes there to buy bread, and she says, if there's eggs, buy 10. So he looks over there and says, they got eggs. I guess she wants me to buy 10 loaves of bread. What she meant was buy 10 eggs. But the wording was vague.
Right.
So.
And that's why we have these different languages for computer and for human. And there are a lot of different languages for computers. There are a lot of dialects, and many of them were invented in ancient times. But all of them are poor. You know, typical language for computer has something like 10, maybe 12, maybe 10, maybe 20 words. That's enough. So put, get, if, then, something like this. 20, it's a good amount of them to describe any algorithm. But if we will speak this way with a human, I think it will be condensing or something like this. It will be
understanding.
it will irritate people, right?
Yeah, I think so. And which is the most popular, I don't know, just widely used computer program language now?
This question doesn't have an answer. You know, there are many fields. There are many fields where languages you can apply the language. So they use one for web programming, another for operational system, another one for something else. So yes, but if we count by programmer's head, you know, the most popular is Java. Because it's a very simple and it's very popular for. I'm trying to recall the word for that. Outsourcing. So it's a simple language. You can teach anyone to program on this language for, I don't know, for a few days. So many cities in India have, you know, 1,000 programmers who work for outsourcing company, and so on. So the most popular maybe is in this metric, but there are many different.
Visual Basic there's a language called Visual Basic for Applications, VBA. Microsoft uses that in its Microsoft Office programs. I can go into Microsoft Word and I can actually write program code in VBA, and I can make Word do what I want. I can write my own little Word macros in computer code. So Visual Basic and C++ are two of the most common application programs, I think. But they're not web-based. Web-based is a different set of programs.
Visual Basic, actually, it's not a language. It's more, we call it a script language. What does it mean? The idea was that any, you know, housewife, anyone, any child can program on that. So
any housewife sounds so nice, Ivan. So strike one, Ivan.
I mentioned a child after all.
No.
You made it worse.
Yes, doesn't matter. Strike one. Anyway.
Okay, so it was the idea, but I don't know how to continue my story because, you know. Okay, but it was the theory. But practice shows that you know, housewives cannot do that.
Okay.
So they finished the experiment with Visual Basic. It's not developed anymore for last 10 years or so. It exists. It will exist forever, but in this frozen state. So they gave up on idea to teach everyone to this language. But many people who wanted to script their work. What script mean? Script mean if you need every day do the same set of actions. Actually, it's a algorithm. Actually, it means that you make that you can make a script for that. and put the script in the word that Visual Basic understand and have the result each morning without any efforts. So it was the idea. And many people like that, and it's popular, but not too much, I think. Not. I don't know why.
Still too complicated for the average person.
Still too complicated. Okay, maybe. But I think that things are changing. Our children can program easily, so maybe in 10, 20 years we can see more and more people who can not only use the computer, but write a simple scripts and simple program for the usage. And I think we can see that every day. It's more and more. Because 10 years ago, there are many people who don't have a computer, did not have a computer. They just don't know why they need that. But now everyone have it, and maybe there will be a day when everyone can program a script, a simple script. And I know that another corporation, Apple, is now trying to make another version of simple scripting. They call it in some different way, I forgot, but it's the same idea. You can just point a few steps to do, and program will do that. Something like this. Okay, looks like we have too narrow topic.
We just have just too few specialists on that topic. Just you, Ivan.
Well, let me give an example. Have you ever, driven to work every day? And then one day you leave your house, you're driving to work, and your mind wanders and you start thinking about things, and suddenly you're at work and you don't remember all the turns and stops and goes, and you go, how did I get here? I don't remember making any turns. Your mind was automatically executing algorithms in your head. Red light, stop. Green light, go. Here's my turn. Turn right, turn left. You leave your house, and then you arrive, and you don't remember the trip. Have you ever done that before?
I think that everyone.
I've done that before. It's like, I don't even remember driving here. My mind was automatically executing algorithms to make me stop and go and turn and slow down and speed up. It was all automatic. My brain was doing it subconsciously.
Yeah, and I usually have a very unpleasant thing, when I'm doing that. When this algorithm works, after that, I just ask myself, did I turn off my iron? And that's the thing. It's like my usual morning question. I don't remember. I never remember. So
yeah, my wife left the oven on one time and almost burned the house down. So after that, every time I leave the house, she'll stop and go, did I turn the oven off? I gotta go check. She'll run back upstairs and check. It's yeah,
it's getting compulsive, by the way. Yeah, I had that compulsion one time in my life. Not a pretty thing as well.
Yeah.
I have a few points. First of all, I used to drive to my work in my weekend many times because I went to the car to drive my wife somewhere to shopping or something else. But I sit into the car and forget about that and drive it to the work. Then I found, okay, it's Saturday. What I'm doing here?
Oh, that's bad.
And another thing about ovens and ironing and all these compulsions, how you call it, compulsions, and. There is I read an article that our brain is usually get used to routine. If you do the same routine all the time, at some point you will forget some points, or you will not be able to remember what you do or not. And there is only way to struggle with that is a checklist, and many pilots have checklists, many cooks have checklists, and it's a thing that's very simple but works. If you have checklist on your door, that means check your iron, check your oven, take key, and go out. It will. And actually, I have many checklists on my work and even in house, just to make sure that you do them. So I found this trick very useful. I can
It's a good
recommend it.
idea. It's a good idea. So another trick that someone recommended is just taking a picture, of all those things. Just take a picture. You always have your phone. Actually, you almost never forget your home at home. So, and when you see the picture and everything is, in this turned off position, so everything is off, so you will be calm. Because a couple of times I had to get back home in order to check whether I turned that damn iron off or not. Yeah, I did a couple of times.
But I think your brain will get used to that, and you will forget to make this photo somehow when it will be a routine for you.
Yes, I can forget to check this checklist as well. Just it's the same. If it is routine, you keep forgetting that. Right.
Exactly. And when I studied biology in my school, they said that we have a special place in our mind for this routine. So the things which we repeat every day, often, they just program it in a special department of our brain, and it's how it's why we can step out without thinking, why we can walk without thinking. So look at the children. It's hard for them, but when they do that 100 times, it's a program now, and you don't have to think about this. And actually, it's not a muscle memory, I think, teacherly. It's some programmed think in, I don't know the English word for this department, but it has a special name of brain.
I don't know.
Okay, let me see in dictionary, maybe. So, no.
Have you ever driven a standard shift car?
Sure.
You've got one hand on the steering wheel, one hand on the gear shift knob, one foot on the brake, and one foot on the clutch. And yet you can operate all four at the same time while you're smoking and listening to the radio. So that's the ultimate multitasking.
And I found in my dictionary the word that cerebellum. I don't know, is it something?
Cerebellum?
Cerebellum.
Yeah, that's part of your brain, yeah.
It's part of your brain where we have this, it's a place where we store this routine. I was told so, I don't know, is it true or not?
Okay. Yeah, the cerebrum is the big part that looks like noodles. The cerebellum, I think, is a smaller part in the middle. And then there's another part.
I think there is in the back, actually, this part. It's and it is somewhere over there, and it's connected with your spinal cord or something like that.
Yeah,
so.
Spinal cord.
And
yeah.
it is.
So yeah, different parts of the brain control different things.
Yeah.
All right.
Okay.
So that probably they're connected with the muscle memory as well, because cerebellum actually it helps. It operates the muscles actually. So cerebellum makes us move, and so on and so forth. That's why probably muscle memory is also involved in those actions as well.
Right.
So,
well, I definitely agree that it's a right term, muscle memory. But I just pointed that there is no place in the muscle to save, this program.
Oh, yeah.
Oh, okay, yeah.
So it's a muscle memory, but the program is stored in the other place.
Sure, everything is stored over there. That's the storage.
Right. A hard drive.
Another question: should we always understand how our algorithms work? What do you think?
You are a programmer, yes.
I'll give you an example: driverless car.
Oh yeah.
Is this algorithm going to save me or save the person in front of my car? I'd like to know.
Okay, so that's important for you.
Well, I would say it's important for me as well.
Yeah.
And I think in near future, when we have this driverless car, it will be a good point for advertisement. Our car always choose you.
You, like the pedestrian or the passenger. But there are driverless buses already, actually.
Yes.
So yeah.
Yes. And many people of industry of IT industry says that it's a near future. It's 5 or 10 years at max when we have all these cars. All cars on our roads will be driverless. All or almost all. Because it's very close now. It's not rocket science anymore.
Mm-hmm. So they will follow the rules, right? So if you're jumping in front of the car, you are out of luck. Yeah.
Gerard, please.
I heard that subway trains could be driverless, but people don't like seeing a train without a conductor.
Right. And this is exactly the case why we have this man on stock market, because it's driverless already for 10 years. But we, I don't know, subconsciously we have to have some people that with the red button just power it off. Don't continue. And answering another Gerard's question, do we programmers always understand our algorithms? And that answer is not, because at this current situation, we invented special algorithms. It's neural networks, and we don't understand how they work. It's not the goal. You just make some goals for this network. It solves that, but we never know why. We don't know how.
Mm-hmm. Nice.
And it's many of these networks works on stock market as well. And the application for these algorithms, it's when it's so many factors that you cannot write an ordinal, usual algorithm, proven one. So there are so many factors that you just feed your neural network with these facts, and you hope for the best. And you have a man with a red button. That's how it's
Wow.
And sometimes that neural networks play a strange tango with each other and bankrupt many corporations. Some corporations. Please, Tishley.
If you read the internet articles in the past 6 months, there have actually been a lot of important, smart people like Elon Musk and Bill Gates and those guys, and they are telling people that AI is dangerous because we don't know enough to control it yet. But people are not listening, and we continue to slide down the steep slope to improve AI, and it's going to end up being someday like Terminator and Skynet, I'm afraid.
But even if we know that for sure, if you know for sure that at some point we will have a Terminator, how to stop?
We need to limit our AI, our dependence on machines.
But it's impossible. Science people have some profits, from these algorithms. When people have profits, it's impossible to stay. You need to make special policy,
Yeah, we're doomed.
Okay. We have some vocabulary today. You can see this on our Padlet. And prophecy is a interesting one, I think. And Tishley just shared a prophecy from Elon Musk, right?
Yeah, basically, that's his prophecy. Even Matrix, if you remember Matrix, how did it start? They built machines, and then the machines tried to take over the world, so they blocked the sun to shut the machines down, and the machines learned how to use human bodies as a power source. So that was a man-machine battle that in the Matrix universe. Yeah.
Oh, another funny example from the talk. I just saw this picture. The one book was sold for $1 million, right?
It wasn't sold. It was just the price was. Yeah, the price was rising actually.
It was the offer, right? Because many people were interested. that, and Amazon program decided that it's a brilliant one. We have to raise the price, and it's how it's work. You know, modern websites are too smart. For instance, if you buy tickets for airplane, they will show you higher and higher prices for the same direction. But if you clear all your history in browser or use another browser, you will start from the scratch. Yes, you can try this trick, you know, at any time. So just decide that I'm flying to Europe, and start to searching for these planes, and you will see that prices slow they will be raised. But then, when you start from another computer that it cannot be associated with you, you will see the initial price. and Amazon do the same. You know, if they adjust prices, offered prices just to demand. So, and some people use it for tricky business. They pretend they write bots, small computer programs. That pretend they are humans, and that bots make interest to some books, and it's why we see these ridiculous prices.
People are engaged in all unnecessary things. You know, I think too many people are doing crap, so not doing the proper things. You know, instead of thinking about building islands, we should concentrate on saving what we do have now. You know, just
yeah.
I don't know. Maybe this island will be Goosing. You know. Many workers will take stones to the ocean, ships, bulldozers. It's good for industry.
Very, very good. Yeah.
Okay, we have a few more anecdotes on this Padlet, and I think that's all for today.
Okay, time's up. Yeah.
Okay. Thank you very much for coming. Thank you. Sorry for this boring topic.
No, thank you. It was actually interesting for me. I don't know much about it, so thanks for explanation.
Okay, and see you tomorrow, right?
Yep.
Yeah.
Godfather. Okay.
Godfather.
Yeah, Godfather. That's right.
And when I decided to opt out, they took me in. Something like this.
But that's the third part.